Hello friends, in this video we are going to write a program of addition of two 8-bit hexadecimal numbers for a 5 microprocessor. Along with the program I will be telling you uh, the instructions that we will use in this program. First of all, in order to start a program, I would like to tell you that there are various methods by which we can write a particular program. In writing this particular program, I am going to use two numbers. For example, say these numbers are 83H. Here H means hexadecimal numbers, and this is 83H hexadecimal value, and second number is 39H. I have assumed these two numbers, both are hexadecimal numbers, and in order to add these two numbers, that means you are supposed to add only these two numbers. So in order to write a program for this particular addition, we will have to start with first of all, you will have to transfer these two numbers to the microprocessor. Friends, you might be knowing that for 5 microprocessors there are some general purpose registers like B, C, D, E, H, L. And for addition, the instruction that you will be using, you may use various instructions. There are different instructions to add two hexadecimal numbers, but I am going to use add R. Here R may be any general purpose registers like B, C, D, E, H or L. So if I am going to write add B, then what does it mean? It means processor will perform content of accumulator plus content of register B, and result will be stored in result will be stored in again accumulator. So don't be confused. It is written like whatever value will be in accumulator, that value will be added to the content of B, and the overall result will be again stored in accumulator. So this instruction is giving you a hint that if you want to perform addition, then first of all you will have to put a number, that means any one of these two numbers, in accumulator, and another number must be in register B. It means first of all we should know the instruction by which we will transfer these two values to the particular registers. So I know it is MVI R, 8-bit data. Here again R may be any of these registers B, C, D, E, H, L. If you are writing MVI B, 09H, simply this instruction will put the value 09H in the register of B of 8085 microprocessor. So after knowing this particular instruction, I am going to sum up everything. That means I am going to write particular instruction like add B, and I know it will perform A plus B. So I have to put one number in accumulator and second number in B, and I already know the instruction that may be used to put any number in any register. For here it is example, I am putting the value 09H in the register B. In the same way I will put a value 83H in accumulator and value 39H in B. So in order to put that, I will write instruction MVI A, 83H. This instruction will put a value 83H in accumulator. In the same fashion, I am write another instruction, that is MVI B comma 39H. And similar to the above described instruction, it will copy or it will put a value 39H in register B. So we have got here add B is performing A plus B, and now A has 83H and B has 39H. That means the content of A will be addition of these two numbers. So now we have got the addition of these two numbers in the accumulator, and in order to store the result at some memory location, you will have to write particular instruction, that is STA2050H. Well, what is this? This is ST2050H. What is this? Basically, this is the instruction that we use to store any value from accumulator to the given memory location. 2050H here is a memory address. That means we are going to put the value of accumulator, and you know at this stage the accumulator will contain the summation of 83H and 39H. So we are going to copy the answer, that means result that is present in accumulator, to this particular memory address, and after that we are going to command processor to stop everything. What is HLT? HLT means halt. That means anything written beyond these 5 instructions will not be considered as a program, will not be considered as a instruction. Now we can write the same program, that means we want to add 83H and 39H by using different instruction. Now I am going to use instruction ADI 8-bit data. Well, what is ADI 8-bit data? Actually, when you write ADI along with any 8-bit data, what is 8-bit data here? Any 8-bit number that you want to add to the content of accumulator. This instruction will perform addition of 8-bit data to the content of accumulator, and result will be stored in again accumulator. So this instruction tells if you want to add any two numbers using this particular instruction, then one of the number must be present here in the instruction itself. Like in our example, I want to add 83H and 39H. So you will have to write one of the numbers along with this instruction here, ADI 39H. So what will perform? Microprocessor will perform accumulator plus 39H, as I said here. 8-bit data, in this case 8-bit data is 39H, and 39H will be added to the accumulator. So when a number 39H is already specified, then we will have to put a value 83H in accumulator, and I told you earlier that instruction will be MVI A, 83H. So simple. Now accumulator contains 83H and we have added 39H to the accumulator directly. And now in order to store the result that is in accumulator to any particular memory location, we will use again instruction STA, and this time I am changing the memory location 2030H. Basically this is a memory location and it depends upon you. Wherever you want to store the result, you will put that memory location here, and after again HLT, that means halt, and program is terminated here. So this is all about adding any two numbers 83H plus 39H without using memory address. I am again repeating, this program is to add any two specific numbers. That means if you will write this program, if you will burn this program in a memory location, in a memory, and whenever you will run this program, always you will be getting the addition of 83H and 39H. That means always we'll get the addition of these two particular numbers. So if you want to write a program of different addition, that means you want to add two different numbers, then you will have to write two different numbers here. Well, this is one of the method. Apart from that, we can use another method by using memory location. I will be telling you that in my next videos. Thank you for watching.